Take a second to look at the things within arm's reach right now. Your phone, your coffee cup, the chair you're sitting in. Every one of those objects started as an idea that had to be forced into the physical world through manufacturing. For a long time, we've only really had two ways to do that. We either take a big solid block of material and carve it down until the shape we want is left, or we melt material and pour it into a mold. It's a system that has worked for centuries, but it's also pretty limited. It forces us to design things based on what a machine can reach rather than what we can actually imagine. We've spent most of human history making things by fighting against our materials, cutting, drilling, and melting them into shape. But there's a newer way of building that's much more logical. Instead of starting with a big block of stuff and whittling it down, we're starting with nothing and adding only what we need, layer by layer. This is additive manufacturing. It might sound like a niche hobby for tech enthusiasts, but it's defining how we will be able to build many more things. From rocket engines to human bone scaffolds and things that were not possible before. To really get why additive is a big deal, we have to look at the two old school ways we have been making things for centuries. First, there's subtractive manufacturing. Think of this like a sculptor with a block of marble, or a machine in a factory. You start with a big solid chunk of material, and you use a high-speed drill to whittle away everything you don't need. It's incredibly precise, but it's also very messy. You often end up with a tiny finished part sitting in a mountain of shavings. Then, we have formative manufacturing. This is the word of injection molding. Think of it like using a cookie cutter or a jello mold. You create a shape, fill it with liquid material, and wait for it to harden. This is great for making a million identical items. It's very rigid. You're completely locked into whatever shape that mold allows. If you want to try a new idea or tweak a curve, you're stuck. You can't just adjust a heavy steel mold. You have committed to that one single design until you stop the entire production line. Both of these methods carry what is called a complexity tax, because you're either drilling from the outside in or pulling a part of a mold. You're limited by simple geometry. If you want to make something with a weird, hollow internal structure or an organic shape that looks like it grew in nature, these tools just can't do it. A drill bit can't turn corners inside a block of material, and a mold can't have trapped empty spaces inside it. That is the physical wall we have been hitting for decades, and that is exactly where additive manufacturing comes in. So how does this actually work? To understand how, we have to look at where it all started. Even though this feels like futuristic technology, the roots of 3D printing actually go back to the 1980s. Back then, it was called rapid prototyping. Pioneers weren't trying to build final products, they just wanted a way to get a design out of a computer and into their hands quickly. In those early days, you might just print a small plastic model, like a simple toy soldier, just to check the proportions or see how the light hit the shape. It was a tool for designers to see their ideas in the physical world before committing to the massive cost of traditional factories. Over the decades, that prototype tool evolved into the serious manufacturing tech we have today. The logic, however, has stayed the same. Every project starts with a digital 3D model, but the printer can't see the whole project at once. It needs instructions. We use a software called a slicer that takes that model and cuts it into hundreds or even thousands of paper-thin horizontal layers. Imagine slicing a loaf of bread into incredibly thin pieces. The printer's job is just to reconstruct that loaf, one slice at a time. The method most of us recognize today is filament printing. You can think of the printer as a robotic, high-tech glue gun. It takes a long string of plastic filament and pulls it into a heated nozzle that melts it down to the size of a needle tip. Following the map from the slicer, the nozzle moves across a flat plate drawing the very first layer in melted plastic. As it hits the air, it cools and bonds instantly. Then, the head moves up just a tiny fraction of a millimeter and starts the next layer right on top. By repeating this thousands of times, the machine can build shapes that are literally impossible for the traditional drill to reach. It's not fighting the material, it's just placing exactly what's needed, exactly where the digital map says it should go. So is this just for hobbyists? Not anymore. We're seeing this tech in some of the most demanding industries on the planet. In aerospace, companies are printing engine parts as single units, instead of welding 50 different pieces together, which creates 50 potential failure points. They just print one. In medicine, it's a game changer for implants. Since everybody's body is different, doctors can 3D print a titanium hip or jaw replacement that's an exact match for the patient's scan. They can even take these parts porous so that the natural bone can grow into the implant. And in construction, we're seeing house printers, giant robotic arms that can extrude concrete walls for a small home in under 24 hours. It's not just faster, it's a way to build affordable housing with almost zero material waste on site. If you can dream it, you can make it. The real reason this tech is so exciting isn't just because it's new, it's because it gets rid of the old rules of design. In traditional manufacturing, there's always been a trade off. If you want something to be complex or custom, it's going to be incredibly expensive. But with additive manufacturing, that complexity tax disappears. The printer doesn't care if it's printing a solid plain cube or a highly detailed, hollowed out sculpture. It takes the same amount of effort for the machine. This opens up doors that were stayed shut for decades. We can now make parts that are much lighter but just as strong by putting material only exactly where it's needed. Think of it like a bird's bone, hollow and light on the inside, but incredibly tough on the outside. Before now, we couldn't really mimic nature like that because our tools couldn't reach inside the material. Now, the only real limit is our imagination. For all its potential, additive manufacturing isn't perfect yet. There are still issues with some technical uncertainties, such as the issue of anisotropy, where 3D printed parts can be weaker along the lines where the layers meet, kind of like the grain in the wood. Figuring out how to standardize quality, ensuring the things produced are exactly as strong when done on different locations. And until those puzzles are solved, this technology will stay in the state of emerging rather than established. But the real impact here goes beyond way just the machines. We are looking at a potential fundamental shift in our global value chains. For the last century, if you needed a part, it likely sat on a cargo ship for weeks to get to you. We're heading toward a distributed future where we stop shipping physical objects and start shipping digital files. Imagine a world where warehouses are just hard drives and products are printed locally on demand when they are needed. It slashes transportation waste and ends the need for massive inventory. We've spent thousands of years carving the world down and fighting against our materials. And now that we are finally building from the bottom up, the way we live, trade, and create is never going to be the same.